If you're a podcast host, listen up, this one's for you. My name is Allie Jackson. I'm the host of Finding Mr. Height, a dating and relationship podcast that I've been doing for 4 years now, sharing my positive and practical approach to dating that's built on my own life experience. And I wanted to share another experience that I've had, my secret behind monetizing my show. It's called Red Circle, and I was just telling my colleague about how much I love their platform. With Red Circle, not only am I getting a seamless hosting experience, but I also love the support I receive in ad sales. It's not just typical ad sales either. It's targeted opportunities based on my show and my life. And the platform is super simple. You just set your preferences and Red Circle matches you with sponsors that align with your show. You can vet every opportunity and their platform gives you great analytics. More recently too, my Red Circle team has brought me opportunities outside of my podcast on social media to really augment the podcast partnerships, bring them full circle. I just can't recommend them enough. If you want to give it a try, go to redcircle.com to get your free trial. That's redcircle.com for a free trial.
Get Certified Together program is created by Technocofe, your free online knowledge sharing website, based out in London.
So that's how the next phase of cloud started. After sharing the resources when they are unused, it really started as a pool of resource which anyone can come in, they can buy, they can purchase, they can rent out for time they want, and when it's not required, they can decommission those services and they can remove everything out of that infrastructure. So that's how whole cloud infrastructure started building, whole evolution took place. So what we moved from is CapEx to OpEx model. Now we are not paid. Hello everybody, this is Devesh back from my London home and you are listening to episode number 18 of the Get Certified Together series. This is episode number 3 specifically for the CCSP series. Now I am all in for anti-global warming movement, but today it's sunny in the winters and I really love it, and weekends are coming up, so I'm really thankful that today it's sunny. In the last episode we got to hear from one of our industry experts on the role of ISC square, CCSP requirement and the difference between CompTIA and ISC square, two different certification bodies. It was a fruitful discussion and I hope you must have gained something new from it, as did I. I know at the expense of that discussion, our first domain was postponed to this week, but we learn with every new experience, and as I always love to say, it's better late to start than never to try. So here I am with this week's episode covering the first 3 subtopics of the CCSP exam. Now for the section 1 of the CCSP exam, cloud concept, architecture and design. I'll be covering different topics ranging from types of cloud deployment, service model of the cloud resources, IAM strategies, storage, and of course different type of threat. But I have to be clear here, this is my 7th retry of recording this episode, and the reason behind this is every time when I was recording, in between I went to relook at the existing recording and I thought maybe this topic I should have told better or in a better or easier way, because we are building a foundation, we are learning about cloud basic, cloud concept, and unless we don't know about what we really are securing, we cannot secure it, right? So that's why I went on to retry recording 7th time, and hopefully 7th will be the lucky number, and this will be a final recording because I have to go and pick up my daughter in another half an hour. So I'll try to wrap up as many topics as I can in the quick 30 minutes. Why I mentioned that we need to build our foundation strong, because unless you don't know what you're securing, you cannot secure it, right? So if, for example, you are hired as a security guard for a building, you should know what that building is made from, what you really are securing, how many are entry exit points, what kind of people are working inside, what are different role of access each individual is having, who is going in and out of that building. So you need to know a lot of things related to that. And beside this, if in case of a mishappening, do we have a spare building where everyone can shift temporarily and start working so that you don't have a business loss? So a lot of things you need to consider before you start planning how you can make the existing security posture better. So same goes for cloud as well. You are securing an infrastructure. If you don't know what that infrastructure is comprising of, what are different key terminologies related to cloud, then you cannot simply secure it. You need to understand that foundation first. And that's why I try to revisit, I try to re-record it because I really want every one of us to have a good understanding of the cloud. We should have a good solid cloud foundation. Now I have worked in cloud for 6 to 7 years, more than 7 to be honest. The time I started, everyone when they used to ask what you really are doing, what is really a cloud, and what you really do day to day, how you access the cloud, what is it really, I simply used to say I just work on someone else's computer using my computer. That's the easiest term you can use. Cloud is nothing but someone else's data center. Amazon, Azure, they have put in a lot of money to create data centers all across the globe. And you as a user or any organization as a client, they are accessing those cloud data center from the internet. They are using those resources. They are working on those data centers, not paying anything for building those data center, but only paying for what they are using inside that data center from their computer. They are just working via their computer, logging into a portal and doing everything. So that's the whole crux of cloud. It's just someone else's computer. So nothing fancy about it. Maybe I can give you a different example. I have a daughter and she sometimes asks for new toys which she saw on YouTube. I don't know why they advertise new toys on YouTube, but we are in this world. I cannot do anything about it. Whenever she asks me about those toys, I, being a good caring father, I simply go and buy it. Very bad, you shouldn't do it. So I just buy it for her. She play for 2-3 hours after school. She go in morning school again. After school, in evening, she play for 2-3 hours, sleep. So all this time when she's not playing with that toy is just simply lying around in my house, staring at my face about and telling me how much money I have invested in it. Anyways, that's the old way of working, where any organization, if their application team comes up with a new requirement, they need a new kind of, maybe they need more resources to build a new application, or they want to update existing application, for which you need more resources, you need more CPU, more RAM, you have to buy a new server, you have to build a new infrastructure. If that application is not utilizing all the resources, or maybe it's only during peak hours when it is using all those resources, and after peak hours in the night it might not be using all the resources which you have already invested in, then those resources or those new infrastructure will be staring in your eyes as well, you being company owner, organization owner. So what happened is, in the next phase of evolution, people start thinking about, by people I should say Amazon started thinking about what happen if during that low usage hours, instead of keep lying that infrastructures unused, won't it be better if they just simply rent it to someone during that period when it's not used? So for example, in the night, if I steal my daughter's toy and give it to neighbor's kid, you just give me £2 or £3 and play with it for the night. Again, very bad, you shouldn't do it. In terms of cloud infrastructure, yeah, that's the beginning of cloud. Companies started renting out their infrastructure to other people, to other organizations, whenever there is a time of low usage. And that's how whole idea started. Our whole cloud infrastructure start, you are using someone else's resources. So that's how cloud started. And now next level of cloud computing started, when instead of you buying anything yourself at all and then renting it out to someone else to recover the cost, isn't it good that I simply take my daughter to a common indoor playground, pay for 1 or 2 hours, she can be, if one day she want to be a cook, she can play in the kitchen area of playground. If someday she want to be a firefighter, she can play in the firefighting area of indoor playground. So same way, if my application owner of my organization someday comes up with, oh, I need maybe 20 GB RAM today, or tomorrow if developer comes and say, hey, I need 3 or more virtual machines today, I'm performing some testing, I want to build some test lab, isn't it good that instead of creating everything on my own, I just simply show those requirements to a cloud service provider, and those resources, those requirements will be fulfilled there. And same like indoor playground, when my daughter is not playing, she is out, someone else can go in and they can play inside as well. So everything is shared, everything is pooled, and anyone can go in and do anything. So that's how the next phase of cloud started. After sharing the resources when they are unused, it really started as a pool of resource which anyone can come in, they can buy, they can purchase, they can rent out for time they want, and when it's not required, and they can decommission those services and they can remove everything out of that infrastructure. So that's how whole cloud infrastructure started building, whole evolution took place. So what we moved from is capex to opex model. Now we are not paying for the infrastructure, but we are paying for using that infrastructure. So now we have 5 characteristics of the cloud. We have Measured services, we are only paying for what we are using. We have elasticity, we can add or remove resources based on real time usage, which is very important. We have on demand self service. We, like I told you, I am working remotely from my own computer to someone else's computer, so I have access of my own portal using which I can create or do anything on a cloud service. We have a broad network access. I can do anything remotely from the internet, and all the resources are shared with other people, other organizations as well. I don't know if I'm creating a virtual machine on a cloud infrastructure of Amazon. I don't really know, and I don't really care who else is creating virtual machine on the same infrastructure. So any technology or any service will be termed cloud if they have all these five characters. It's very important to remember they should be having all of these five. If anything is missing, that service will not be considered as a cloud service. Or any service provider, if is missing any of these five characteristics, they cannot claim that they are cloud service provider. So cloud service provider should be having all these five characteristics. I'll repeat again: measured services, elasticity, on-demand self-service, broad network access, and shared pool of resources. And like any service or any application or any software, cloud itself also have building blocks, also have key infrastructure components which comprise together and creates a whole cloud infrastructure in itself. These building blocks are compute, network, and storage. Compute, if you are working in IT or if you have read about computer anywhere, compute is nothing but processors. You really need something to process those algorithms, those models, those applications, anything with processing power. And compute actually provide processing power. Amazon provide compute service as a EC2 instance. Azure provide it as a virtual machine. And I mentioned that everything must be accessible from the internet. So network is second key component or second key building block. Everything which you are creating on the cloud must be accessible, must be having a proper networking component, should be having a public IP address, should be having a secure way of communication between two applications running on different regions. A lot of different ways of putting in whole network topology together, but network is second key building block. And last is storage. Any kind of application which you are creating, which you are running on the cloud, will be having some kind of data, will be storing some kind of logs, will be creating some kind of information which may be or may not be critical, but still you have to ensure that that data is stored. Maybe you can remove it after every 1 week or after 15 days, or maybe you want to keep it for whole 1 year. It's upon the organization how long they want to keep the data, what is the criticality of that data, but all this information need to be stored somewhere, and that storage is the third key component of your cloud infrastructure, one of the key building block. And why I am telling you guys that these three are key building blocks, because ultimately you have to pay as you go, right? All the services which you are using from CSP is being monitored, and you are paying for whatever you are using, and your CSP, your cloud service provider, will charge you based on all these three components. It will charge you based on what kind of compute services you are using. It will charge you based on how many public IP address you are using from the network which you have been allocated to. It will be charging you based on whether you are using solid state drives, SSDs, or you are using HDDs or tape drives. So it will charge you based on what kind of information you are storing, how you are storing it, and do you want to keep it for longer period of time. All these X number of factors are directly and indirectly related to these three key building blocks. So it's very important to understand about them. Again, I'll repeat: compute, network, storage. Now, cloud deployment strategy is a big task and requires people with different skill sets to work together for the solution to go live in production. It is very important that you have the right kind of people with correct competency in your team so that they can manage your whole cloud infrastructure properly. You should require people with advanced skills to act as an administrator or to act as an architect. You should require people with advanced development skill to be a cloud developer. You should require someone with basic network knowledge who just know a bit about in and out about cloud infrastructure. So for day-to-day operations, you need a cloud engineer. And of course, you need someone from storage or data side as well, someone who is very good in how your information is stored, how you are backing it up, what should be RTO, RPO policies, how really you want to design the disaster recovery of your stored information. So you need different kind of roles together. They work together in any organization to make a full-fledged cloud team. So cloud team is not someone with basic idea of cloud engineering, or someone who is only very good in particular cloud designing skill, but he don't really know about, or he don't really care about development, or he don't really care about storage or other aspect. You may have a one individual or three or four individual having all this knowledge, which is very tough in current scenario. Then you can have a different people with different kind of roles working together as a team and performing this whole activity together. So that's the whole idea behind cloud, is why cloud really came into picture and how it is transforming everything. Even if you are using a mobile application on your phone, it is in backend running on the cloud. Your Netflix, your Amazon Prime, everything is based out, is deployed on top of the cloud itself. And if your organization is still using the old way of having everything on-prem, deploying the whole infrastructure, that approach need to be slowly changed. And it is really changing with time. More and more companies, more and more organizations, they are moving towards deployment on the cloud itself. When we are talking about deployment on the cloud, now we are moving towards next subtopic of the exam, which is different type of deployment model and different type of services. What I mean by different type of services is we had five main characteristics, but as a customer, as a user, as someone who want to use the cloud, who want to use the cloud services, there is no hard and fast rule that you have to deploy or you have to run your application in a specific way, or you need to use these particular solutions offered by your cloud service provider. Each cloud service provider provides a different kind of service model, and it's your call, it's your decision to how and which services, which are the one which is most effective for your use cases and for your team to use, for your developers to use. We have three kind of service model: infrastructure as a service, software as a service, and platform as a service. First and foremost is infrastructure as a service. So infrastructure as a service, by name itself, it is showing that you will get a baseline infrastructure, but virtualized infra, which includes your virtual machines, which includes your maybe Kubernetes cluster. Everything you as a cloud user have to deploy yourself. You will be the one taking ownership of creating those VMs. You will be deciding what images those VMs will be using. If there is a security incident, you are the one who is responsible for patching in. You are the one responsible for deciding what traffic is going in and out. You are responsible for port security. You are creating the infrastructure on top of existing hardware, which anyhow is managed by the cloud service provider. But infrastructure on top of that hardware will be created by you as a cloud user. Now, there are multiple advantages of using infrastructure as a service. You have more control on what you are deploying. You have more control on deciding what kind of software you want to use, what kind of operating system you want to use. You can easily scale up or scale down based on your use cases, and you have a better idea about capacity requirement. You can decide better on when you really want to have more virtual machines to be deployed, more worker nodes for your Kubernetes cluster to be deployed. You have better visibility. You can decide in a better way, and what kind of infra suits your organization's need well. And of course, everything is metered. Pay as you go still there, so you are paying for only those VMs, or only those, for example, only those network which you are creating, load balancers which you are creating. You're only paying for those equipments, those virtualized infra which you are creating yourself. So everything is still metered, having better visibility, and top of that, you are not managing hardware yourself. So you are reducing the cost of having your own hardware, having the ownership of your whole infrastructure yourself. From infrastructure as a service, we move to next service model, which is platform as a service. So platform as a service is an advanced form of infrastructure as a service. In infrastructure as a service, you will get access, you will be creating VMs, you will be creating virtualized infra yourself. In platform as a service, you will get that virtualized infra already set up by the cloud service provider. They will put all the binaries, all the operating system which you need for your team. And once you access those applications, once you access those virtual machines, you can go in there and play around. You can do whatever changes you want. For example, if you are building a website, you already have HTML, CSS code with you guys. Your team want to run on a virtual machine, want to test it out in the real environment. There are two ways to do it. Either you buy an infrastructure as a service, you create your own virtual machine, install relevant packages yourself, install relevant operating system yourself, open all the required ports, and then you put in your code, paste it there, and see how your website is looking like. This is the one way doing testing using infrastructure as a service. In platform as a service, cloud service provider will provide you access to a virtual machine based on your requirements. So it will already have all relevant packages, it will already have all the required binaries, required files. You simply have to put in your code and try to access your website. You are getting the whole system already, whole platform already pre-created by the cloud service provider. You are just going in there and testing your code. So it revolutionized whole software development life cycle. So that's why platform as a service was not something which came in day zero itself. When cloud came, cloud started with normal infrastructure as a service, but slowly more and more companies, more and more organizations are taking advantage of platform as a service solutions provided by different cloud service providers. You have multiple advantages. There is no need to build any environment yourself. You just submit to the cloud service provider and you can get 5 or 6 different kind of testing environment yourself with different kind of binaries, different kind of files, different kind of operating system, and you simply have to go in and test your application. And of course, advantages like scalability, advantages like metered usage is still there. You are simply paying for what you are using. And last is software as a service. So software as a service, as name suggests, it is the scenario when you are getting whole software, whole applications created by your cloud service provider for your usage. So what you get in this is you simply get access to a already created application. You are just going in and doing it for your day-to-day use. You have seen this software as a service in various forms. Already you must be working on it. Your Gmail, your Google Drive, App Store, everything is an example of software as a service. What you are doing is you are just downloading the application and using it. You don't care where that application is running, what kind of framework it is using, who is responsible for patching that application if something goes wrong. What you are responsible for is only using that application and make sure that you are using that application as per your need, as per your recommendation. You cannot see anything about underlying infrastructure, anything related to where and how this application is being deployed. So software as a service is very commonly used, because what you actually doing in real life is you are downloading that application, you are getting hold of that application and using it as per your use case. Neither cloud service provider have any recommendations related to how you should be using that application, nor you as a user have any say in how that application should be deployed on a hardware, on a virtualized infra. One is a user and one is a provider. So there is no overlap. You need to make sure that you are using your application as per security standards, and cloud provider is making sure that that application's underlying infrastructure is secured, it's deployed properly as per recommendation, it's always up and running. Cloud service provider is the one who is managing everything related to auto scaling, everything related to elasticity. You are not doing anything, you are just paying for using that application. So you can understand that software as a service reduce your cost immensely. You are not deploying anything yourself, you are not buying any license yourself, you are just using the application. So you don't need to get even a team of cloud engineers. You simply need the team of application developers, or maybe people who want to customize that application once it is already deployed. You even cannot do any changes in the backend code because you are not aware of how that application is been running and what kind of framework that application is using. Moving from cloud service model, we have cloud deployment models as well. So you need to make sure that you understand clearly difference between a service model and a deployment model. So service model is the kind of services which you are using from your cloud service provider. You are using infrastructure as a service, or platform as a service, or software as a service. In deployment model, cloud infrastructure will be created from scratch and will be made available to the end users. Now, if that cloud infrastructure is deployed and made available to everyone on the public internet, we term that as public cloud. Public cloud is very commonly used term. Most of the time when we say public cloud, we only hear about AWS or Azure. These are all public cloud providers, and the deployment model is public cloud. Of course, we can deploy a cloud on our own premise as well. As an organization, I want to keep my whole data inside my organization building. I don't want anything to go outside. So I can deploy it as a private cloud model. What happens in private cloud is I'll be setting up whole infrastructure. I'll be hiring team of cloud admin, cloud architects, data storage architect, and I'll ask them to manage this whole infrastructure in-house. So still I'll be having customer and client, but those customer and client are the stakeholders inside my organization only. So for example, my HR team who want to store data on that private cloud, they will be my one customer. My sales team who want to store data on that cloud, they will be my another customer. All in all, but everything is private. We are not sharing anything on public internet. No one from outside the organization can get access to my private cloud. Everything is private, everything is in-house, or everything is on-premise. There are different benefits of public cloud and private cloud. Public cloud is obviously easy and inexpensive because everything is set up by someone and you are just using it. So you don't need to care about setting up that infrastructure, setting up those hardware, cabling, cooling, all those expense, all those efforts are now gone. You simply are using it as way you want. If you want to use software as a service, if you want to use a platform as a service or infrastructure as a service, you can select that relevant kind of solution provided by your public cloud provider and just use it on the go. So it's really inexpensive to set up. Private cloud, on the other hand, gives you more control. So you can really decide yourself where you want to keep your data, how you want to secure it, what kind of encryption mechanism you want, and what should be your ownership, how many days you want to retain your data inside your on-prem storage backend. So you can have more say in doing a lot of things on the whole infrastructure itself. You don't need to think about if I go for this particular solution, or if my security team is recommending this kind of encryption, do my public cloud provider provide it? You are not concerned about any of those aspects now, because everything is managed by your own cloud team, and your cloud team can install, can customize, can do anything as they require according to the recommendation, according to the standards set by the organization. Let us club these two different cloud models now. We have a public cloud, we have a private cloud. There may be a scenario where your organization might find some services or solutions offered by public cloud more relevant to their day-to-day work, more relevant to their day-to-day use cases, but still they want to keep some information, some data in-house on premise. They don't want to keep everything on the public cloud provider. In that scenario, we can build a hybrid cloud infrastructure where some aspect of the application, some aspect of my organization data will be stored in the infrastructure which is set up as part of private cloud, while those applications which are maybe public facing, my company website or my external customer portals, those application can be run, can be deployed on public cloud provider. So we can have a mix and match model, and this kind of scenario is termed as hybrid cloud. In hybrid cloud, you will have a private cloud and a public cloud setup. Both may be connected via a VPN gateway or via direct peering. It's upon your public cloud provider's capabilities, as well as your private cloud solution architect or cloud architect's capability, how they want to plan their design. But you can have multiple ways where you can use hybrid cloud. We have another term used these days, which is not part of CCSP, but I can let you guys know a bit about it, which is multi-cloud. Multi-cloud is not hybrid cloud. Make sure you get a clear idea. In multi-cloud, we have multiple public cloud. Hybrid cloud also have multiple cloud, but they are private and public. If you have more than one public cloud providers, if you are deploying one application in Amazon as well as another application of your organization deployed on Azure, you are not using hybrid cloud. You are using a scenario of multi-cloud. So make sure you know the difference between multi-cloud and hybrid cloud. Alright, I really wanted to cover more topics in today's episode, but seems it's going more than 30 minutes now and it's enough for 1 week of study. I suggest you go out, check more information on cloud computing, check more information on different type of service model and different type of cloud deployment models from online blogs, from YouTube videos. So make sure you get your concept clear from having a multiple knowledge sources, because it's very important as we move into securing the cloud, as we move into this cloud security journey. We should be knowing about different type of cloud, how any organization can use cloud services, what are different type of service model, different type of deployment model. So those foundations are very important. I'm sure you must have learned something related to cloud computing today in this episode. In next week's episode, I'll be covering more security concepts relevant to cloud computing, design principle of secure cloud computing, and of course we will evaluate different type of cloud service provider, because every cloud service provider provide different kind of services. They are unique. Sometimes they have similar kind of offering but with a different name. So we'll try to evaluate and compare different type of cloud service providers as well. That's all for this week's episode. See you. Ciao.
Thank you for listening to Get Certified Together. If you loved our content, then please like and subscribe from your favorite podcast platform so you don't miss the notification for our next episodes and announcements.
If you're a podcast host, listen up, this one's for you. My name is Allie Jackson. I'm the host of Finding Mr. Height, a dating and relationship podcast that I've been doing for 4 years now, sharing my positive and practical approach to dating that's built on my own life experience. And I wanted to share another experience that I've had, my secret behind monetizing my show. It's called Red Circle, and I was just telling my colleague about how much I love their platform. With Red Circle, not only am I getting a seamless hosting experience, but I also love the support I receive in ad sales. It's not just typical ad sales either. It's targeted opportunities based on my show and my life. And the platform is super simple. You just set your preferences and Red Circle matches you with sponsors that align with your show. You can vet every opportunity and their platform gives you great analytics. More recently too, my Red Circle team has brought me opportunities outside of my podcast on social media to really augment the podcast partnerships, bring them full circle. I just can't recommend them enough. If you want to give it a try, go to redcircle.com to get your free trial. That's redcircle.com for a free trial.